All right, let's look at problem number 2. My manganese is going from a +7 to a +2, so it's gaining 5 electrons. My sulfur is going from a -2 to 0. So that is losing 2 electrons. So I know I'm going to have this 2-5 business going on. All right, let's figure out what those half reactions are going to be. Now there's a lot going on in these reactions. So if I'm going to write the half reaction involving the sulfur, I don't necessarily need all that other information. I just need the S, -2, going to sulfur with 2 electrons. And then for the reduction reaction, I'm going to just look at the polyatomic ion. I'm going to keep that permanganate ion. And I keep the permanganate ion all together because it's covalently bonded. It's covalently bonded together. And I'm going to take the Mn+2. So I'm just taking the ions in this case. Okay, so basically like this, kind of like the spectator ions. And then I'm going to have you go ahead and complete your method for adding the waters, balancing the hydrogens, balancing the electrons, and combining everything into that equation. So let's pause and you work out what the combined redox equation is going to be. Now here is my combined net ionic redox equation. Now let's figure out how to put this into a form that's a molecular form. My 5s minus 2s, those would have come from the H2S, and H2S is an acid. So the 5s2s would have come from 5 H2S's, and that takes care of 10 of those 16 H pluses. So I have 16 H pluses, but then 10 of them are taken up in that H2S. So if I subtract out those 10, that leaves me 6 more H pluses that are unaccounted for. Then I'm going to look back at the original equation and see, are there any other places where there were H in the reactant? And I see I had this HCl, so I had 2 sources of the acid. So the other 6 H plus would have come from 6 HCl's. And that arrow here is not a yields arrow, it's just saying that the 6 H pluses would have come from those 6 HCl. Now let's look at my permanganate. So I had 2 permanganate anions, so those would have obviously have come from 2 formula units of potassium permanganate, 2 KMnO4. Now let's look at the product side. I have 5s, that it matches the 5s on the reactant side. Then I have 2 Mn+2s. So my Mn's are balanced, and where would those Mn+2s have come from? They would have come from 2 MnCl2s on that product side. And then I have 8 H2Os. So let's check on my Cl's. So on the reactant side, I had 6 HCl's. So that gives me 6 chlorines that I need to account for. And on the product side, so far, I'm only seeing 2 times 2, which is 4 chlorines. So I have this discrepancy. I have another discrepancy in the form of the potassium. On the reactant side, I have 2 potassium spectator ions, so I know I'm going to have 2 potassium spectator ions on the product side. So if I look at the equation at the top of the screen, I have KCl as a product on the product side. So that is going to end up being 2 KCl's in addition to all those other products. And that accounts for the potassiums, and that accounts for those extra 2 Cl's that we needed to account for. So let's rewrite all of that. Now I have 5 H2S and 6 HCl and 2 potassium permanganate is going to yield 5 sulfur and 2 MnCl2, and let's see if I can squeeze this in here, 8 H2O and 2 KCl's. And you can double check and make sure everything is balanced on both sides.